So hi everyone, I am Parampreet Singh. If maybe some of you know me, some of you may don't know me. I am a student in this degree. I'm in degree level, and I have been taking sessions from 3+ years on Python, on machine learning, and some on MAD1 and other subjects as well. Um, so you might have referred to my earlier sessions or maybe some notes of MAD1, DBMS and all. So today we will be doing the MLP OPP 1 practice. Okay, so this is our practice session, which is being done in a collaboration with Nilgiri House. So thanks to Nilgiri House for the collaboration and support. So today we will go through this Kaggle notebook. We will write code for each and every question. The questions are similar to how they are in the previous OPP plus the mock ones. Okay. This is the MLP OPP session. The Python OPP one was conducted and one will held tomorrow. Okay. So as you have questions in mock or the previous uh, like MLP OPP, there are two parts: data pre-processing, and the other is model building. Okay, so similarly we have these two parts here. Okay, in each part there are almost 12 to 15 questions, so in total 30 questions are there. Plus I'll share um, for almost like around 40 questions, one more Kaggle notebook at the end, with which you can practice, and some more notebooks as well for your practice. Okay, if you are not from your laptop or desktop, please join from your laptop and desktop and refer to this Kaggle link. Okay, practice along. I won't write code my own or on my own. You have to tell me the code and the understanding. This will be more of an interactive and discussion session. Okay, so are you guys ready? Just give a thumbs up, or even you can speak, you can text, anything. Okay, just please be interactive. Okay, and I hope the font size is clear, everything is clear, right? So uh, let's start. And the questions are based upon the dataset, one of the dataset. And yes, I'll share the notebook link and all the links in the YouTube video description as well. Okay, so the dataset which I am using is if I expand it. Okay, so the dataset which I am using is the dataset which you have in your one of the assignments. Okay, MLP assignments. So the like there is a competition, right, in your assignment. So the same dataset I am using here, you can just use the training dataset of that, the competition, Kaggle competition of your assignment, or you can just use the dataset from here directly. I made it public here. Okay, so how to load? Well, in your OPP you will get the dataset link and collab link. You can download the dataset and upload it in your collab, and just copy the path similarly how I am copying here. Okay, the code will be same, just the UI is different. So let's first start with the first question. In the data pre-processing, how many samples are there in the dataset? But before doing that, we need to load the dataset, right? So let me just run the first cell. So this has provided me the path of the dataset which I have. So how can I load the dataset? Anyone?
We can use read CSV.
Yes. So let me store the dataset in df. Okay. pd underscore read underscore pd dot read underscore csv, where I will pass in the dataset path, and then I will do df dot head. What does df dot head do?
It will
First
serve
five
top five,
rows.
Yes,
top
first
five
five
row.
rows. Okay, so these are some warnings for the values and all. You can ignore that. Okay, so these are the columns which we have. Now there is one thing, there is a column and there is a id column, okay, and that is kind of an like index column, okay. So how can we make this as an index directly? If yes, how? While loading the dataset.
We can put header maybe.
Okay, header, are you sure? So um, the if I'm not wrong, it would be this index parameter, or maybe header, or I think index underscore colon. Yes, index underscore colon, and yes, now we have the id column as the index column, okay. So these are the columns which we have. Now the first question, how many samples are there in the dataset? How can we check the number of samples?
df dot
Same. Yeah.
df dot shape, okay, and the shape provides us a tuple having the number of rows comma number of columns, okay. So these are the how many samples do we have? It's 10,000. And this 8, does it contain like all the columns with id, the index as well, or does it exclude? What do you think? If I'm like getting the number of columns, is it including the id as well? Yes, it is excluding, because we have made it as index column, okay. So now, like if we just want to extract the number of rows, we can like do a little bit of indexing, 0, okay. So at the 0th element we have the number of samples. Now the second question is, how many unique locations are present in the dataset? So there is a column named location, okay. So if I want to just check, sorry, so what I will do is, just I'll put in d and in square brackets the column name. So these are like this is the whole location column we got. Now how can we check the unique values? How can we extract the unique values?
dot n unique
Okay, I got two answers, dot unique and n unique. So
dot n unique
okay, uh, the unique is to get the all the unique values in a specific column, okay. So what does dot n unique do?
Number of unique
Yes, number of
values.
unique. Now these are like how many unique values we have in the location column, okay. So this is one way. Another way we can do is just directly get the length of all the unique values, both way, okay. This time now we are getting a little bit different answer. How is that
Can we
possible?
use count also?
counts null also.
Yes, it okay. Can we use count?
Unique dot count maybe.
uh dot count, okay, we can use that count as well. uh okay, numpy, and okay, okay, it is giving us a numpy array, not data frame, not a series, so we cannot use the count. Now why it was giving us one extra like value number when we are doing len? So someone like said it was counting null as well. So like that is also being considered. So how can we prevent that? Like okay, this way is fine. What about this way? Like how can we prevent that? Okay. Well, this is an easy question. -1, that is fine. What if uh, we have nan and null? Like okay. Well, I think for as of now, this would be suffice. -1 we can do. There are other ways as well. We can just do a filtering step before that, right? We can exclude all the null values and then we can get the count. So there are many ways to like get answer of a single question in like programming as well as in data analysis. Okay, so I'm just showing you multiple ways. Now the next question, what is the average house price in lakhs? So all the house prices are in lakhs only. So how can we get the average house price?
Dot mean function.
Yes, very easy. Dot mean. Okay. So this is the average, and just make sure when you are like submitting the answer in the like exam link, they will specify like whether you have to provide in the round off to 2 decimal places or 3 decimal places. Okay. This is not live anywhere. You can watch the recording in the YouTube channel. Okay. So if they like ask you to do the rounding and all, so make sure use the round function. Or okay, if they do not ask you to round, provide the answer in some round value, just copy paste the whole answer and that's fine. Okay, so sometimes they ask, sometimes they may not ask, so it's up to them. Now, how many houses have more than 3 bathrooms? So if we go to again dot head, so there is a like each row is a house. Okay, so there is a column called bath. Basically it specifies how many it specifies like the number of bathrooms do we have in each house. So like in first house we have 2, in the third house we have 3, in the fourth house we have 4 bathrooms. So how can we do this? So this is one of the like conditional filtering question. First we have to create the condition and then we have to count. Anyone knows?
We can use a lock, I think. Dot
Yes,
lock. Yeah.
we can use lock. There are many ways to do it. Now
Uh,
df dot
After applying condition, can we do values underscore count?
uh,
df
value underscore count will give us in a different like after applying the condition you are asking.
Yeah.
Well, you can do that, but then you have to accumulate all the answers. Okay, because it will categorize the answer in each unique value. Okay, so df.log. Now what's the next step?
df
df
dot
of
bath
df of bath.
Okay, then
greater than equal to 3 maybe.
yes. So
Oh, greater than 3, yeah.
this is the condition which we are applying. More than 3, if they say like uh more than equals to 3, then we can apply equal to as well. Okay, now
Can we use df dot bath also? I think.
yes, we can use. Okay,
Yeah.
both are fine.
Mhm.
Now we are getting all the like the complete data set, but this time if you see we are getting only 1725 rows. Why? Because now this condition has been applied to the whole data set, and this is like the filtered data set we are getting. Now if you check the bath column, we will not like all the values will be greater than 3 in the bath column. Okay, so this is like the filtered data set. Now how can we get the count? We can just do dot shape, right? Dot shape and 0. Now this is one way. Again there are many ways. We can just directly do this as well. um, like if we do this, we will get all the true and false values, right? So this is basically telling us in which row this condition is true or in which row this condition is false. Okay, now how can we get the total number of uh, like the true value answer of like the correct answer, this one,
Dot
total of
sum
true?
maybe.
Yes, dot sum. Okay, it will give us the same answer. Now there are again many, there might be any like many other ways to do this. Okay, so there is no specific one code. I just want you to like know this. कि ऐसा मत सोचना कि if I have not written this code then I will not get the marks or something like that. There are many ways. If you are getting the correct answer, then that's fine. Okay. Now, what is the average price of top 10 most expensive houses? Now, this is a little bit um, kind of like complexity has increased, but again, it's an easier question. So, if we divide this question into various parts, so it is asking like average price. This is one thing. Okay. Average price of what? Average price of top 10 most expensive houses. Okay, so can we do something like this? If we get top 10 expensive house, so first, okay, sorry, first if we get this, then we can simply get the average, like do the average of these top 10 most expensive houses. Can we do that?
Yes. Yes.
Okay,
Yes.
so how to do?
So DF presses, I think price or dot
Okay,
m largest, and then we can put tab there.
okay, yes. So um let's first get all the price values. Okay, now there is a function called n largest. Okay, by default if we run, we'll get top most 5 like expensive houses, or in like it's in the decreasing order, descending order. Okay, so this is like the most first most expensive, this is the second, this is the third, fourth, fifth. So how can we get the 10? We just have to pass in the, like there is a parameter called n inside, like how many rows do we want exactly. Okay, so if we pass in 10 here, we'll get the top 10 most expensive houses. So this is completed. Now this part is left. How can we do? It's very easy. Anyone else?
Dot
Dot
min.
mean.
Dot
Yes,
mean.
dot me. Okay, nice. Easy questions, right?
Yeah.
Df price, sort values. Yes, we can do this as well. Again, there are many ways to do. Okay, see, same answer. Okay, so what we are doing here, uh, we are basically sorting the whole price column in descending order. Ascending equals to fall means descending order, and then getting the top 10 values. What if okay, instead of this, let's say I do not provide like ascending equals to false, then what uh, one modification do I have to do in this code to get the correct answer? Okay, right now how we are getting the data with this?
We are arranging it
We
in
can do
ascending order.
descending true, I think.
No, there is no descending parameter, there is only ascending parameter.
It's in
Okay,
ascending order, right?
yes, it's an ascending order. So there is a function called tail, if you know, right?
Yeah.
So you can use that. Tail means to get the last n values. So by default it will give us the last 5 values. Okay, if you check, these are the like all the values which we were getting from the normal n largest. Okay, now we just need to specify 10 here to get the last 10 values, and then dot mean. See, again there are many ways to do a single question. Okay, it's up to you, whichever way you like. Yes, we can do this as well. Okay, we can sort the data using Python sorted function, and yes, then get the top 10 and just choose the mean. Okay, now how many missing values exist in the total square feet um, feature? So there is a feature called total square feet. So we can see like in the fifth row there is an an value. So now they are asking how many missing values are there. So if we just see this, so this is how we are like getting the this is the data we have in the total square feet. How can we calculate the nan values?
Is null dot sum.
Okay, yes. So is null dot sum. So is null basically gives us all whether each row is having null value or not. Again, there is another function is na. Is na is null both are same. Okay, You can try any of these, and then we are just doing the sum. Okay. So this is one a, yes, is and a is null, both are same. Now there is one function which I generally prefer to do at starting, not info. Anyone knows what does it do?
Is the data types null values?
Yes. So if we see, it gives us a high level overview about the data set. Okay. All the columns and the non-null count. Okay, so like in each column, how many non-null values do we have? So these are like the total values, and if we just like, we can simply subtract from here, subtract this from the total, we can get how many null values do we have here. Okay, so you can verify from here as well. If we add 33,967, we'll get 10,000. Okay, so this is one way to check how many columns, or like which columns are having null values. This is just a high level overview. Okay, it is not like telling us a very in a very descriptive manner, but it is a very good function which we like, which I prefer to do at starting. Okay, now how many houses have 3 bedrooms and at least 2 balconies? Now this is again we have now here two different conditions. First is 3 bedrooms. Okay, and it is not more than 3, less than 3, it is just exactly 3 bedrooms and at least 2 balconies. So at least 2 balconies means more than, greater than 2 balconies, can we say?
Yeah.
Okay, so these two conditions have to met, and like there is a and between these two conditions. Okay, it doesn't mean like if there are 3 bedrooms and 1 balcony, that is also counted. No, there has to be 3 bedrooms exactly and more than or equal to, like basically more than 1 balcony, we can say. Okay, so now you guys have to tell me how what is the code for this. And so here we are having the size column. Basically it tells us how many bhk does that is that uh, houses. So if we see first, like let's analyze how the size column is. Okay, so there are many values, and if we just do dot unique, so these are all the unique values we have. Okay, now there is a pattern being followed, and what is that pattern? Can you see? Like all of these are having like bhk bedroom and all, but the first like the first number, or like the first two characters, are the like number which is specifying how many bedrooms do we have here, right? Can we say this? The first two characters, or even first character as well, but that would be like a little bit tedious to check how to get like the first character, first two, or if let's say there are 3-digit bedrooms as well, well, that is a very 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 rare case, but still. Okay, so how can we check like there are only 3 bedrooms? Like we need to consider only those rows which are having sort of this and this, these two values. Okay, rest all we do not want, right? So how can we get that? Okay, yes, we can use.
str dot split.
Okay, so again there are many ways. So if we do dot str, what do we? Okay, well, this gives us a generator instead of printing. Okay, so someone said split. Yes, we can use split as well. If we do split, so we will get all the values, yes, splitted by a space with the first element as like the number of bedrooms, and the second is like whether it's bhk or bedroom. So we have to consider which value, like which element, first or second?
First,
First.
First. How can we do? Just this.
Yeah.
Okay, but no, this is not the right manner. So this is only giving us a first row. How can we do that? Anyone? Okay, so
Lambda function.
yes. If like I think you must have explored the apply function, right? So there is a function called apply map where you can use a lambda function. I hope you all are like clear with what a lambda function is. If not, okay. How many of you are not clear with lambda function? Okay, everyone is. That's great.
No, I don't know actually.
Okay. Okay, we are getting float object is not subscriptable. Well, this is weird. So what could be the issue? So we are having the series here. The split data type is object dot apply. It is giving us the same. Yes, we can do this. There are again many ways. So just like x is a, if we see type of x, it is a list. Yes, we can do this x of 0. Okay, float object is not subscriptable. There is an issue, and why this is happening, if anyone knows. Okay, someone has shared the regex. Okay, yes. Well, if you see, let me add a code block here. Not unique. Can you see there is a nan value as well? This one. So that's why we are getting like float is not subscriptable. Okay. So what we can do, we can put in a condition here. If type of x is list, else just 0. So now we got all the numbers here, but are these numbers actually numbers? We don't know. What's the data type? What do you think? The 3, 2, 5 and all, it is showing us object. What is the actual data type here?
String.
String. Okay, so how can we convert it? Like we can just directly check here with this 3. Okay, this also works, or we can convert further. If you want, we can convert here it into an integer. Okay, both are fine. Again, up to you, whichever you want to use. Now this is the first condition which we got. Let me just put it here. Well, this is a very long way. Okay, now let's see a very like a small way, shorter way. So one has shared, yes, this what I was about to do. Let me copy it. So as we have seen here, like there are only two types of values which are having 3, right? 3 BHK or 3 bedroom. So we can just specify these two in the condition like this, and we will get the same answer. Okay, if we do okay, a.empty, we have to like df size equal to, yes, or, and let me put in here. Okay, let me just put it in the df. Sorry. Again, I'm getting an error. What could be the error? Df size is that, and it's in the 3 bedrooms. Okay, if I just put in one condition, oh, I have to put it in value is ambiguous. I think I'm doing something wrong here.
Maybe or doesn't work in this.
Oh yes, sorry. uh well, thanks for reminding.
I think single will work.
Yes. I'm just confused with the syntax. Okay, so this is how we can do very basic filtering. uh, Apologies for like the error. Yes, so first we are putting this condition and then this condition. Okay, and like we have to combine both of these condition, and this is a pipe operator. Pipe basically works as an or. If we like want to use and, how can we use and? There is an
ampersand.
ampersand. Okay,
Campus.
so with the help of ampersand we can use and if we like want both the conditions to be satisfied, then we will use and. Okay, but if I do and here, how many rows will I get?
0.
0.
Right, there cannot be one single row having both the values in a like single column. So now we got the number of rows here, like basically all the houses which are having 3 BHK. So the first condition is done. Now the second condition is more than 2 balconies. Let me just put it here. Now how to get like more than 2 balconies? So if we see in the data set, we are having this balcony column, a very refined column. We do not have to pre-process it. Sorry, balcony, and so greater than equals to 2. Can I do this? Greater than 1.
Yes.
Yes, right. Now we are getting all this, and we can just like um okay, let me just cut it from here, and now um sorry. So this is the code. Now you guys have to tell me where I am doing wrong. Like a certain part is wrong here. I'm getting like
And
yes, 3
instead of
bedrooms and all. There should be and, right?
Yeah.
So if I let me break down this condition first. uh, okay, so this is like the first condition. Okay, and this is the second condition, and in the first condition we have these two, like it can be either any of these two, and this is sorry, great, we can do, let me just show it. Parenthesis does not match. Oh, yes. So now we are getting all the required rows. How can we get the number of rows if we want? How many houses? Just do dot shape, right? Easy. So the main thing was to do this filtering, because this column is not much pre-processed. That's why like it took a lot of time. There is another way using string, which is like comparatively more easier than both of these. Let me just copy this one. So what I can do here is, let me remove this and this extra braces as well. So dot string dot contains. Anyone of you know what does this contains to? It okay. It simply checks whether that specific substring is in the like uh, each row in each string or not, like in each row. Okay, similar to the split, like split is being applied to each row, right? So contains is being applied to each row, and it is checking whether each string is having this 3 or not. So we have to check like this only. Okay, now there is a like ambiguity. What can be, like if I comment it out? So right now we are getting 2229. Okay, from this is the correct code. Now this code is not correct. We are getting 2376. Many extra houses, like more than 100. So what is the ambiguity? Can you see in the data set? I'm just checking for 3. What can be the ambiguity?
13 is there.
Yes,
It might.
13 is there. Okay, again we have to like pre-process it somehow. We can apply another condition if you want, um, or like okay, I would leave it to up to you. How can we like exclude these value, this value from the size column. How can we apply another condition here, like by putting in another and? How can we do that? Okay. Sorry.
I think not.
Yes, not. And for not, like negation, we have to use this tilde. Now you can provide me with the complete condition to get the answer. So this is like your task. Now we have the answer here. Let's move on to the next question. Took a lot of time. So average price per square foot. Very easy. So the square foot, if we see, there is a total square foot like column. Now per square foot we need the average house price. So how can we get that? Okay, first price column. Okay, this is like the price column we are having. Now average price per square foot. What is, I think should be like, what is the sum of something like that. What is the average price per square foot? Okay, for each house, if we want to get like the average price per square foot, like this is the price and this is like the total square foot, so like 77 lakh and the square foot is 1030. Okay, so how can we get the average price of this just for one row, for a single row?
Price divided by square feet.
Yes, divided by square foot, easy thing. Total square feet. Okay, now we are getting some nan values and all. We can handle those values, right? We have to just filter
Uh,
out the data set. Yes.
I think the price is already in square foot. Like if you see some prices are 80 and all.
um, it's a total
We
price,
just need.
I think. Maybe,
Okay.
maybe or maybe not.
Okay.
I'm not sure. Yes, we have to handle the nan values first, right? So there is a like existing thing which we did, this one, right? It is not the PYQ. It is like the same Kaggle assignment, like the Kaggle assignment competition which you have in your one of the assignment, weekly assignment, like week 4 or 5 maybe. Okay. Now we have to remove the nan values from here. How can we do so? So like let me just create df2 and let me just copy. Okay, not copy this. How can we get all the like rows which is having not non-null values for total square feet? um like this is the total square feet. If you see, there are 33 null values, right? We have to exclude those values. How can we do that?
Drop NA.
Easy. Okay, so df dot drop na we can provide in the column as well. Okay, let's, so I just want to, if I just right now, okay, let me not yes. Now if I do, it is removing all the like null values from all the like all the rows having the null values. So I want to only remove the null values from the total square feet. How can I do that?
We can do df dot total and then we can like apply drop and
Df dot total and
then dot drop and
uh, dot total. Okay,
total is square basically, I think.
this is something new I have heard about.
Total is square and then we can use drop and I think row name column name basically
Okay,
from
well,
which
with the drop and only we can do that. Okay, so if I just provide a subset like which column specifically I want to drop from. So I can just provide total square feet here. Takes one position. Okay, I have to, I think, provide the subset. Yes. So now it is dropping from the total square feet only. Okay, so this is a subset parameter in which we can specify from which columns we have to drop the like null values. So see, this is 9967. We can verify from here 9967. Okay. Now from this we can just simply do the average price per square foot. So df2 and df2 price divided by df total square feet. Now okay, sorry, df2. Now we are getting like the answers in rows. Of course we do not have to provide in. I think I have not provided the full question. It might be like sum of average price house or something like that. If we just do the sum, how can we do the sum here? If I want to get like the average price per square foot, or what can be the better way? What is the okay average price per square foot? So I think that could be something like this. Like we first sum all the price values and then sum all the total square feet values, then we can get the overall average price per square feet for all the houses. Okay, so I hope this is clear.
Dot mean won't work. Yeah.
Dot mean, yes, it can work. Okay, let's so df2 then for the mean, like mean of, basically we have to get average price per square foot. Yes, for a single column we can get the mean, right? Like either for price or for square foot, and then we can somehow do, but here we are like just adding up all the prices of all house and adding up all the square feet of all house, and then we are taking the average. Instead of sum we can put the mean. Well, it's up to like what sort of analysis you would like to do, but directly dot mean won't work. Correct me if I am wrong somewhere. Okay. Now the next question, imputation. What does imputation mean?
Replacing the value.
Yes. So basically imputation we do for replacing the missing values or the NaN values, right? So it is saying replace missing total square feet values with the median of the column. Okay. So first you can make it a new column and use mean on it. Yes, yes, you can do that. No, with the median of the column, replace missing with the median of the column. So well, I think we'll use the simple imputer further. Okay, how can we get the median of the column, total square feet column? Very easy.
We don't have to do that. I just think just apply the strategy.
Yes, I'm doing without the simple imputer right now.
Okay, okay.
So if I just choose the median function, this is how we can get the median value, right? Median square feet. And now how can we get the like all the like how can we fill the missing values? Basically we
Dot
have to
fill
replace
NA.
missing
Dot
values.
fill NA.
Yes. Okay, many of you know. Dot fill NA, with what value do I have to fill?
Median
Mean.
square.
Median
Yes,
square feet.
median square feet. Median square feet. And now after imputation, what is the new count of missing values? What do you think? What will be the new count?
0.
0, right? It's like more of a logical question rather than doing. We can verify it here as well. Then is some 0. If we are getting 0, then that means we are doing fine. Instead of that, like, they can ask anything. They might ask like, what is the sum of the total square feet? What is the average of the sum, like, total square feet? Okay. uh, so what if, like, they ask what is the average of the total square feet after imputation, after replacing the null values?
Dot mean.
Dot mean, easy, right? We can get the mean here. Now, all of you know, like, how to use simple imputer. um okay, how many of you does, I think, okay, let me just do that. So there is a like, in the scikit-learn library, I hope you have used scikit-learn library. uh, there is a function, basically a way, like a tool, simple imputer, which helps us to impute the missing values with some value, or it's like some strategy, as like
Yeah, yeah, yeah.
someone has just shared. So how can we first, like, use that? Import that.
Impute,
Impute,
impute.
yes, from
Yeah,
sklearn dot impute, import simple imputer.
yeah.
Okay. Now we have the simple imputer here. So let me create a simple imputer. Here we have to specify the strategy, like with what values do we have to fill in the missing values. So, like, uh, I'll provide the strategy parameter with median. That means I would like to fill the missing values with the median. Okay. What is the default strategy?
Mean.
Mean. Okay. If you have, like, practiced enough, you know, like, this is the default. Now I have to like, fill in the missing values with the median. How can I do that? Just only on the total square feet. There are two methods. Further, we can use, there are in total 3 methods. What do you think? Which
Dot
method should?
fit transform, I guess.
Yes,
Yeah.
dot fit transform. Okay. Well, there is dot fit, there is dot transform, and there is dot fit transform. Anyone would like to explain the difference in all three? Anyone? Okay. What does dot fit do? Uh,
Fits the test data, training data accordingly.
yes. Here we just fit in the training data, and it basically compute the values. So if I do total square feet, it will not produce anything. Okay. It is asking me to reshape it because it's a single. I can reshape it -1, 1. So, um, oh, it's a series. What I can do here is, hmm, so now we have the simple imputer. So what does fit do? Fit basically actually compute all the values. So, oh god, like, there is a strategy transform get params. So there is a imputer dot get params. So this is, I think, not running. It is not running. Transform is applied. Yes, but it is not running. That markdown. Hmm. No, get params, I think there is some value. Okay, so let me just give a very basic brief. Fit basically computes the value using the strategy upon from training dataset. Okay, and then there is transform. This is for the fit and this is for the transform. Transform basically impute the missing values with the computed value, and there is fit underscore transform. So fit underscore transform computes and impute the missing values. Okay, so it do both of the things basically. It simply we can say it calls both of the functions inside. So if I do df fit underscore transform, we'll get the answer here, all the the data in without any null values. We can verify here as well. It's numpy array again. We can convert it further. If I just show dot mean, so we are getting the same answer here. Okay, that means it has fitted all the missing values with the median. There are different strategies. What are the different strategies? There is mean, median, and for the mode, anyone knows what is the parameter value?
Most frequent.
Most frequent. Okay, there is constant as well. Okay, where we just have to if we want to just impute some constant value, and then we have to provide in the constant value in another parameter as well, right? And yes, fit and fit transform both applies on like applies on training data set, these both. Okay, and transform, like fit cannot be applied. You don't want to apply fit underscore transform or fit on test data set. Why? Because test data is something we have not seen, right? The model have not seen, so we do not want to compute values upon that. So the model is only based upon the training data set, so that's why we use fit or fit underscore transform on training data set only. So this is the difference basically, very rough difference in all three.
Can we say that fit is used to learn the parameters from the data?
Yes, we can say that.
Okay.
Now the next question. Yes, so the same question can be do in two different manners, whichever way you feel easy, you can do that. Now, how many new columns are created? Encode the area type column using one hot encoding. What is one hot encoding? Anyone would like to explain?
वो न्यू कॉलम क्रिएट कर देता है 0 1 से.
Yes, so it basically create like k new columns, where k is how many unique values we have in a specific column. Okay, let's say if in a column there are 3 unique values, so if we apply one hot encoding on that column, we'll get 3 different columns. Okay, where one is the value where that actually has that value is present and rest are zeros. So let me show you. Okay, first let's use from the scikit-learn. How can we import one hot encoder? So there is one hot encoder, again a similar tool, something like this, to do one hot encoding. Anyone?
Dot pre-processing.
Yes, dot pre-processing. From dot pre-processing, one hot encoder. Okay, so we have the one hot encoder. We will do in a similar manner. So OHE equals one hot encoder. Now OHE dot, now it also has the same basically all the pre-processing and all the tools which we have in scikit-learn for the data pre-processing have these three methods in common. Most of the tools like fit, transform and fit transform. Okay, so fit underscore transform df, and we have to provide area type. Okay, just before that, df area type dot unique. So we have four different unique values, right? So how many columns do we get after doing one hot encoding on this?
4.
4, right? If I run, so we are getting sparse matrix here. I can just pass in sparse also. Yes. So now we are getting some sort of like this array. What does, like, how can we interpret this array? If you check area type, so on the like first 4 rows, if you see, the type 1 is there. Okay, so the first row is having 1 1 1, like first column is having 1 1 1, and the rest 3 columns are having 0. That means this is for type 1, this is for type 2, this is for type 3, this is for type 4. Okay, now if you see the last second column here, the type is like the type 3 we have. So 1 is there and rest all the columns are having 0 value. So this is how we interpret one hot encoding, and it's very useful in machine learning in data pre-processing. Okay, and now it is asking how many new columns are created. We can do, like, we can answer it without even doing one hot encoding, just by like checking number of unique values, right? Because that many number of unique columns it will create. Was that easy, the question? I hope the question was easy. And now scale, price and total square feet using min max scaler. Again we will use min max scaler. It is again one more tool from scikit-learn. Scalar dot pre-processing, import min max scaler. Scaler, I'm just using it here, scaler. Won't it change the column number of entire data? Column number, yes, the order will be changed here. Just here we are just applying the one hot encoding to a single column. If you apply one hot encoding to the whole data set, basically specifically for the object data types or like the string values, like you will see the columns will get changed, the order will get changed, but you can like handle that. That would be easy. It basically gives us like many there are many helpful parameters which one hot encoder gives us, with which you can exactly get like which column is one is here, one is specifying which value for which column. Okay, I'll show you later in the process. Now min max scaler we can do very easily. What is the mean of scaled price column? So scaler dot fit transform and df price total square feet. Now here we have applied the min max scaler. It is just to scale down the data set into a certain range. How can we get the mean of the scaled price column? It's very easy. Anyone would like to like share? Okay, so we can just get the price, not exactly the price column. Yes, so what we can do here is all the rows of 0th column, this is like the price column, and then do the mean. So this is like the mean of the price column, or we can just get the price column, get rid of the total square feet as well. Okay, drop rows with missing values in bath or balcony. Bath or balcony. Okay, there is a function which we have used
Can
earlier.
you explain one more time this one? Yeah.
Okay, min max scalar. So min max scalar, I don't remember the exact formula. It is like a scaling technique to scale down the dataset to a certain range. Okay, I think it's from 0 to infinity. I'm not
0
wrong.
to 1.
0 to okay, 0 to 1. It will scale down the dataset to 0 to 1.
No, no. My particular confusion is how you got mean here.
Okay. Uh, so this is the like a 2D array we are getting, right?
Hmm.
So first, like we are just simply doing the okay, someone has shared. So we are simply doing a very basic indexing, you can say. Like get all the rows, okay, of the 0th column. This is like the 0th column. This is the first column. Okay. So
Then we did mean.
and then we will just do dot mean. Okay.
Okay, okay, thank you. Yeah.
If you have done numpy, you are like very clear with this syntax. Okay, drop rows with missing values in bath or balcony. How can we drop the rows in these two columns, specifically these two columns only? Remember drop NA function,
Subset.
subset.
Using.
Okay, very easy thing. You just need to provide the column names, bath, balcony, and we'll get like all the rows which are having non-null values on bath and balcony column. And how many rows remaining? Just do shape and we'll get then this is the answer. Now split the dataset into 70% training and 30% test. This is a very interesting thing which all like especially I like to do, and this is a very initial step for the ED and everything. How can we split the dataset? There is again a function from scikit-learn and train test split. How can we use this?
Model
Model
selection.
selection,
Yeah, model selection.
import train test split. Now train test split will pass in the dataset.
Firstly, we need to, divide x and y, I think.
Yes, that's okay. Now, if you see the data set, the data frame right now is having all these columns. Price is the target variable. I hope you all are clear with what target is, right? This is what basically on which this is the uh, dependent column, and these are all the independent columns. This is what we have to predict for the test data set. Okay, so we will separate out uh, the x and y. Y is the target variable and x is all the features. Again, how can we do? Drop NA or anything we can do. Okay, df.ilog. I hope you all are like familiar with this syntax. Df price. Okay, if you see x is this what we got. Basically we are taking all the rows and all the columns till -1, and like the stop value is not considered, right? This is from the Python. So -1 means the last column. We are excluding the last column here. Okay, the last column itself is the price column. So x is,
We can use drop also, no?
yes, there are many ways. Okay,
Yeah.
so x dot shape comma y dot shape we do. So this is what we are having here. Okay, now we have to provide x and y here. Now what is the test size? Can I provide 30 here?
No,
0.3.
0.3. Yeah.
Okay, I need to provide in the range of 0 to 1. Okay, so now we will get 4 different like data sets, different data. Okay, what that will be, let's label them. So first is the x train, because we have passed x at starting, so we are getting x train first and then x test. Okay, then y train, y test. Okay, if you see x train dot shape, x test dot shape, so this is what we are having here. Okay, all the 7 features. Just now the data set is split into 70:30 ratio. Okay, same way for the y as well. Okay, now there is a the question is not specified, we don't need it here as well. There's a parameter called shuffle. Let's no, not shuffle, random state. What does random state?
Random.
Anyone knows? Random state. Okay.
Will store same data all the time, I think.
Yes. So random state basically maintains the randomness. Okay. Like if I just run this piece of code, if you just run this piece of code in your local or in your Kaggle notebook or collab without specifying the random state, we will always get the different data set. If we specify some random state value, that will basically maintains the randomness. So doesn't matter how many times I will run this piece of code, I will always get the same shuffled data set. Okay, this is just to maintain uniformity, randomness, uniformity. Now,
Reproducibility, we
yes,
can say.
reproducibility we can say. Now create a new categorical column, price category, based upon price. Well, this is the EDA part, but we do not work with the price specifically. Okay, but yes, this can be one of the useful features for models. If you are working on competition, you can do this. So if you see, this is like the price we have, this is in lakhs, so you have to create a column called price category based upon these conditions. Okay, if it is less than 50, it will be low. 50 to 100 medium, 100 or more than 100, it will be high. Okay, so how can we create the price
We can
category?
define a function, I think, and then
There are many ways. Okay, so if I just define a function, we can do that as well, like categorize price. Okay, it will take a price. Okay, and it simply returns whether the price comes in the low category, medium category, or high category. Okay, what if okay, not that. Yes, so if price is less than 50, I will return low. And if um, 50 less than equals to price less than equals to 100, return medium. That's it, and return 5. Are you all clear with this piece of code?
yeah.
Everyone is clear? Okay. Now, so this is like the function we have created. Now we just have to apply this function to the price column. And okay, you tell me, how can I apply? I just said the same word. We can use uh, directly apply function. Categorize price. And yes, now we got like uh, the output here for each row. Like this is coming, the first is coming in medium, second is also in medium, third is low, high, medium, and so on and so forth. Okay, now how can we create a new column in our data set? Price category.
Df of price category is equal to all this. Yeah.
Yes, so values count. Values count we cannot exactly use here. So if I just do price category, okay, we'll
Yeah, it will
have a
work.
new column. If I do df dot head now, So see, here we are having a new column, price category, and it is matching the condition. Less than 50 it is low, more than 100 it is high, and for rest the medium. Okay, question was easy,
Yeah.
a bit lengthy for you maybe, but it's very easy. Okay, uh so by the way, how long will the OPP be? 2 hours.
Yeah.
Okay, so even like with the discussion and too many approaches we did in like 1 hour 15 minutes, right? The data pre-processing. And one thing, like I want to share it with you all. Data pre-processing will always be a little bit lengthier, okay, than model building, because we have to like brainstorm how can we apply each and every category, like strategy and all the things. Okay, so make sure you try to do it as soon as possible. Okay, if it is done in 45 minutes, then आपका your building will be done in just like 30 to 35 minutes. Okay, now the model building part. Just before coming to the model building, let's remove the price category. Okay, we do not need it specifically. So df dot drop columns price category. This is the data set we are getting, and what does this parameter do?
It will remove from main data, I think.
Yes, from the main data set itself, so we do not have to like create a new copy of the data set. Okay, oh, it will basically override the old data set. Now
Yeah.
let's start the model building. So far, like I hope a little bit practice of yours is done on the uh, pre-processing data pre-processing part. Okay,
Yeah.
shall we continue on model building? Just give a thumbs up if you all are ready. Just want to see how many of you are not sleeping. Okay, okay. Now how many samples we have to first split the dataset into? Let me just copy paste this code. Okay, test sites 3, random state 42, exchange.shape, samples are there in training set, we can just answer 7000, right? What is the, oh okay, train a ridge regression model and with these parameters, and then calculate what is the R to score on test data. Okay, now from sklearn, how can we import the ridge model?
Linear model.
Yes, linear
Yeah,
model.
linear model.
Import ridge. Okay, so there is ridge, lasso, linear regression. Now I'll just write in ridge with these values. So alpha equals to 10, solver saga, there are various solvers, and let's maintain the random state here as well. Okay, 42 to keep the uniformity. Ridge dot fit. Dot fit is basically to train, right? I hope you all are clear with this. Now ridge dot fit, our data set is okay, could not convert to string to float. Oh yes, we I forgot. Okay, how can like forgot. So this is like, these are all what we have here. So what do you think, what should we do? Basically to convert into a data which is model ready. Basically all the data should have numeric values.
Yeah.
Let's
Encoding, scaling, and encoding.
okay, let's not do scaling right now. Let's like create our own approach. let's impute, okay, all the category columns with less than 5 unique values. Let's do one hot encoding. Okay, and all the categorical columns with more than or equal to 5 unique values. Ordinal encoding. I hope you all are familiar what is ordinal encoding. And numerical columns. Okay, fill missing with mean, that would be suffice. And for the categorical column, like columns, fill missing with, what do you think, with which, like we
Most
More
frequent.
word would be okay. Yeah.
okay, most frequent. So let's do this. Okay, now we have to sort of create a pipeline column transformer. This
Yeah.
would be a big not a big task, much bigger, but yes. Let's first separate out what numerical columns do we have and what categorical columns. Okay, calls. So all the numerical columns I would like to keep it here. X dot select d types, exclude object. So what does this do? It basically select all the columns which are not having the object. So I am excluding all the columns which are having object data type. Okay, and if I just do dot columns, so we'll get all the numerical columns. Now how can we get the categorical columns? Cat calls.
X dot select d type.
Include is equals to object.
Include equals to object. Okay,
Yeah.
very easy. Num calls comma cat calls. So we have all these here, num and categorical separated. Now for the categorical columns, well, that would be very much bigger, but okay, let's just do ordinal encoding as of now. Okay, just to like reduce the time. It will take a lot more time to do all the things. Now let's first import the pipeline. Okay, anyone knows what a pipeline is? Okay, pipeline is like if you have to do some sequence of steps, okay, on some data set. So you are basically creating a pipeline, like step 1 is this, and like step 1 is something, step 2 is something, and so on and so forth. Okay, so here if you see for the categorical columns, we need to create a pipeline. Okay, and the pipeline will be, first we have to fill all the missing values with most frequent, and then we have to do ordinal encoding on it. Okay, so this is a pipeline which we will create. Now how exactly do we have to create pipeline? First we'll create a list of steps basically. Okay, and for each step we can simply provide some name. So first we are filling the missing values. Okay, so we can say imputer. Okay, and what sort of imputer we are doing? So we'll like use simple imputer. And what would be the strategy?
Mean. Oh, yeah, I think
Most
Most
frequent.
frequent.
most frequent. Yeah,
Okay,
yeah.
so most frequent, and we can say sparse equals true.
Yeah, I have a question. What Sparks do basically?
Sparse matrix is like, have you seen generators in like um Python? Sparse is basically, it doesn't provide you the whole matrix at once. It basically saves the RAM. It's an efficient way. We can do the operations directly without loading all the metrics like the whole array at once. Okay, it
Okay.
basically gives us the like high level overview of the data set. We can do all the operations on it, but we will not load the complete data set on RAM. So that is why sparse is useful. But right now, like, let's keep it as false. Now the first step is to fill all the missing values with most frequent. The second step is ordinal encoding. Okay, so this is the first tuple. Now the second step is encoding. Okay, encoder, ordinal encoder. We have to like import the encoder as well. So it is in pre-processing ordinal encoder. Okay, so these are the two steps majorly we have to do in the categorical pipeline. Type error, simple imputer got sorry, it is not in the simple imputer, it was in one hot encoding. So see, this is the pipeline. So here two steps are there, like simple imputer and ordinal encoder. So can you see this very thin line? So it is basically specifying, like, first whatever data set we will pass into this pipeline, first this will happen, the simple imputer, and second the ordinal encoder, like it will happen. Okay, so these are like, this is what like a pipeline is. And what is, like, why is it useful? It is useful, like, if we have to do many pre-processing steps on the same data set, then why should we create like df2, df3, df4 and all? We can just do all everything at once sequentially using the pipeline tool, okay, in scikit-learn. Now before proceeding further, if you see, for numerical columns also we have to fill missing with mean values. Now there is a thing called sklearn.compose column transformer. Anyone has used column transformer? Okay, so column transformer is basically if I just scale draw let's say uh, this is like, these are the numerical columns, okay, and then we have some categorical columns. Okay, now there is some pre-processing we have to do on categorical, right? Like some steps which we are doing here, I know. And there is some pre-processing we want to do on numerical, just like we have here. For the categorical we have two, and for numerical we have this. Now for categorical, what we can do is we can create a single pipeline. Okay, that is fine. Like we can just create a pipeline here. Now for this we do not need a pipeline. Pipeline basically performs the method sequentially, okay, all the pre-processing sequentially. Now like we will do some we will do some transformation here and some transformation here. At the end we want to combine these two data sets into a single data set, right? है ना?
Yeah. Yeah.
So how to combine them? One thing is we can do dot join, dot merge and all, but that would be very tedious. Rather, what we can do is we can create a column transformer. Okay, column transformer. Now what's the difference? So pipeline do all the tasks sequentially. Column transformer, it basically do all the tasks parallelly. Okay, so this will happen parallelly, this will happen parallelly, and then both will be combined into a single data set. So at the end we will get a single data set with all the transformation. Like the transformed data set, and it will be of like num plus scat both. Okay, this is what is the use case of column transformer, and it is very useful. If you like use it properly, it is very useful. Okay,
Can we use pipeline with numerical data also?
yes, it doesn't like it is not dependent upon what data type do we have. It is for both.
Okay. Like step by step things.
Yes.
So yeah.
Okay, now we have like column transformer here. So for column transformer, uh, there is a like parameter called transformers. Like each thing is a transformer. Uh, this is one transformer. Like the pipeline is some sort of a transformer which is transforming the data set. This is one transformer. Like here we have for the numerical columns the imputer, simple imputer. This is one sort of a transformer. Okay, now for the let's first do with the numerical. Same syntax. Okay, a list of tuples. Okay, so on the numerical columns we will do so num transformer. If I write, or I can just write num, that would be enough. Num comma, now what sort of transformation do we have to do on numerical columns? We have to simply fill missing with mean. How can we do that? Simple imputer. Do I have to provide any strategy here for
No.
filling in with mean? No. Okay, so that's it. Now on which columns like do I have to do here? Well,
Num
this is
underscore call.
right. We have to specify the column. So num underscore columns, num underscore calls I'll use here. This is one. Now second, the categorical. Okay, categorical transformation. Now what I will pass here? Can I pass these two steps here? No, I just need to pass in the pipeline. That's it. Okay, nothing else. Now what I have to pass in here? The categorical column, scat underscore calls. Okay, now these two steps, and that's it. Sorry, I'll just write transformer here, transformer, and see the same visual diagram which we have seen here. This is one parallel task, this is another parallel task. Okay, for the num we are having this task, for the categorical we are having these two tasks. Okay, are you clear with both the pipeline and num transformer?
But
Sorry,
what about other column?
yes. So do we have any extra columns apart from numerical and categorical? No. Okay, let's say
Okay.
if we have any extra column, what we can do is we can just use the remainder equals pass through. Okay, this will keep all rest of the existing columns. Let's say we are sorry, not in here, sorry, my bad, in transformer. Okay, here remainder pass through, it will keep all the existing columns. Okay, is this clear to you all?
Can you repeat that remainder thing?
Okay, uh let's say uh let me just give you some example. Okay, uh let's say we did ordinal encoding, or okay, there are let's say 12 features. Okay, n equals to 12, ordinal encoding on 5, and like numerical imputation on 5. Now rest two columns. Okay, so if we see here the current structure, it is keeping like the 5 columns here, the 5 columns here, but what about the rest two columns? It will be like removed, but we want to keep those rest two columns as it is. We do not have to apply any sort of transformation. So how can we keep that those columns? Just by using this parameter remainder equals to pass through. It means all the remaining columns on which we are not performing any sort of transformation, it will simply pass them. Okay, It will just pass them from like whatever we are getting from input, it will simply give us the as it is as the output. Okay, is this clear to you all?
By default it will drop columns if we
Yes,
don't.
by default it will drop the columns. Okay, now if we run, so see, now we got another parallel thing here, which is remainder pass through. Okay, is the pipeline and column transformer clear to you all?
Yes.
Okay, what about others? I know it is a little
Yes,
bit
clear.
lengthy, but it's very useful, especially in OPPs, plus in like quiz 2 and NTM. Might be in quiz 2, but in NTM, like you will see this for sure, like with too many pipelines being applied. Now, what we have to do? Remember fit underscore transform. Okay. Uh, that is just we have to do here. Now instead of x, let me just yes. So on x train, what I will do here is transformer dot fit underscore transform on x train. Okay, and see, we got our data set. Now you will see like a very weird sort of data set, but see, it is having all the like rows as it is 7,000 rows with all the features. We were having 7 features, right? So that's why we are having 7 here. If I do one hot encoding here, we will get, okay, do we get extra feet like more than 7 as the answer or less than 7?
More than 7.
More than 7, right? Now if you see right now, we are getting a very weird array. Like we are not able to understand which uh, column is of like what is the label of each column, है ना? So how can we keep that? What we can do is transformer dot set output, and here I'll just pass transform as panda, so it will basically uh, give us a pandas data frame. Now see, we got the original data frame which we passed earlier. The output is in data frame itself. Okay, now the column names are little bit varied, but the all the main names are same, like the total square feet is there, bath is there, just that for all the numerical columns, num underscore is num underscore underscore is added here. Okay, for all the categorical columns, cat underscore underscore is added here. And how these two are added? From these num and cat. Okay, if I just specify cat as like cat e, so see, we are getting cat e. Okay, that is why we specify like the name here. Okay, uh so are you guys clear with this? A very big transformation, not a very big, but a very useful one. Okay,
Yeah.
great. So what I can do is extrain tf. Okay, now on xjust also I need to do. Can I do transformer dot fit underscore transform?
No,
No.
No,
just transform.
just transform. Okay, with the help of fit, it will compute all the values for simple imputer, for the ordinal encoder and all, and it will fit in those values here. Now we are getting a value error here, found unknown categories. Okay, what is this issue? So see, when we are dividing the data set now, so like some in, let's say a column has there is a column which has 10 unique values. Okay, when we split the data set into train and test, okay, train and test, train will have like, let's say after splitting, train has 8 unique values and test has 2 unique values. So we have like basically the transformer has learned the parameters based upon these 8 unique values, not on these 2 unique values, right? These are new for it, है ना? Can we say this?
Yeah.
Okay, because we are fitting on the training data set, it will only learn these 8 unique values. That these 2 unique values are new to it. Okay, now how it will handle that? How should we handle that?
Splitting should be proper.
Splitting
Sampling
should be
should be
proper,
proper.
but that is like a very, you can say, a very tedious thing. Okay, like right
I
now we are
think
having
we
on a
should do
sample.
shuffle, maybe it will work.
Not exactly shuffle. We do not have to do anything in splitting. We can do that. Okay, that is one way. But
Yeah.
with specifically in ordinal encoder, we are getting that. Okay, if you like just debug it, you will understand in the ordinal encoder we are getting. So how can we handle that? Um, I exactly am not sure the parameter how to handle unknown values in ordinal encoder. Handle unknown. Okay, so by default the handle unknown parameter has error value. That means it will raise the value error. Okay, so what we can do is in handle unknown, like let's pass the use encoded value. Okay, so what does we mean by this? Like if there is some new value which we face in the testing data set, how it will handle? It will handle by whatever we pass in unknown value parameter. Okay, let's say we pass in 5 here. That means if there is any, like right now we are getting these two as the new two categories, right, in the test data set. So it will simply replace these two values with the value 5. Okay, is this clear to you all? Like let's say for the 8 unique values we are getting 0 to 8 as the like digits, right, with the help of ordinal encoder. Do you guys agree? Sorry, 0 to 7, है ना? If there are 8 unique values, for each unique value there will be a single number assigned. Now how to handle these two unique values? We can either specify -1, like if any new value we get, we can specify it as -1, or let's say 8, or let's say 9, or let's say some 5 or some value. Whatever value we think would be good, we can specify. Okay, some uses like 0 here, some put 0 here, some put -1 here, some put some like desired value. We can use anything. Okay, like 0 can work as well. So now if I run okay, again we are getting the used value for, okay, 0 is used, so we cannot use the 0 here. So what we can do here is we can just specify -1. Now -1 we did, and now our data set is transformed. Okay, so how can we check extrain df? So this is our training data set and test. See, the number of rows remains same, number of column remains same, but the data set is now ready for modeling, है ना? Is this clear to you all? Okay, well, I think we almost spent 15 to 20 minutes here, but I hope this major thing is clear to you all. How to use pipeline, how to use column transformer, when to use what. Okay, can I give you one task for practice? If you all like, if even if any one of you would like to do, if any one of you would like to do, what you can do is the same thing, like categorical columns, do one hot encoding on columns having less than 5 unique values, and ordinal encoding on greater than equal to 5 unique values. This is like your task. you have to just simply add one more transformer here, a nested transformer here. How to add? This is up to you. Okay, try it yourself, figure it out. If you are not able to, just put it in like whatever your solution is in the comments. Like whatever approach you have tried, I will share you the exact solution. uh, After trying at least for 15 to 20 minutes, you can do chat gpt and all, but ऐसा मत करना कि just starting में just do chat gpt and get the answer. Okay, so can we proceed now to the model building, the very interesting thing? Okay, how many of you are not sleeping? Just give a thumbs up.
Here in Rich, can you explain alpha and solver?
Okay, these are mainly for like uh, regularization. These are the mainly regularization parameters. The alpha is the how much like weight should we penalize. Okay, the alpha value specifies that. I'm not going in much into the theory, but this is mainly for penalizing the weights, basically to reduce overfitting. Okay, the alpha value we provide, and there are multiple solvers like by which way you have to, you want to get the answer, like, so this is what we can do here. Now instead of xtrain, what we will do here is we will pass xtrain tf. Now if we run, so this is our model has ran successfully. How to get r2 score?
Rich dot school.
Ridge dot score. What parameters do we have to pass here?
Extreme TF or
No,
X-test.
x test gf and
And
y test.
white test, yeah.
Okay, so this is the r2 score. Again, put if they ask like write it in 3 decimal places, then round it to 3 and provide. If they ask 2 decimal places, then do. If they do not specify anything, just copy paste the whole answer. Okay, now which feature index is most important? So if you see ridge dot coef, what what does this mean? Coef, coefficients.
Coefficients.
Coefficients are like all the weights we get for each feature. We have some weights. Okay, I hope you know like how these models work under the hood. Now which feature index is most important? Like whatever feature is having the highest coefficient value, highest weight value, that is the most important. So if we see max, so this is the maximum. Okay, but we want to provide the index, feature index. How can we get the index instead of the actual maximum? So we know this is the maximum, but let's say there are 70 columns, then how will you figure out manually? Remember there is argmax. If anyone of you remember from numpy, argmax or argmin, anyone knows what does it do? Argmax. Okay, see what does argmax do is it
It
first.
provides the index for the maximum
Yes,
coefficient value.
yes. Now the same code we will use here for the least. What do we have to change here?
Argmin.
Argmin. Okay, it will take the minimum value and provide us where the minimum value is, like the index. Okay, 5. And you can check by checking all the coefficients. You can cross verify. So ridge dot coef, and this is like the minimum value 0.001. Okay, now perform grid search CV. Interesting questions comes here. So grid search CV with SGD regressor. Let's import them. Okay, how to import SGD regressor? Linear model. What is SGD regressor? Anyone knows? Okay, no one. uh have you heard about gradient descent?
Is caustic
Stochastic
gradient
Stochastic
gradient
gradient descent, yes. So it's the stochastic gradient descent. What's the difference in gradient descent and stochastic gradient descent? Okay, I like brainstorm and tell me.
It is an optimization algorithm.
Both are both are same. Like, what is the difference in normal gradient descent and stochastic gradient descent? There are like many variants of gradient descent. Okay, how to import grid search CV? Model selection. Import grid search CV. Okay, now we have imported these two here. So the next task is with these parameters. So you know what does grid search CV do? I hope you all know. How many of you doesn't know what does grid search CV do? Okay, have you heard about hyperparameter tuning?
Yes.
Yes. So hyperparameter tuning is basically
Updating the value, updating the weights of coefficients.
no.
Gives the best parameters.
Yes, gives the best parameter values. Okay, so like these are the three parameters which we have in SGD regressor. We will pass in each value, okay, and we will train model for each combination. So like these two values, like for L1, the model will be trained with these three alpha values. That means three different models, and with these three alpha values, for each alpha value, this is the tolerance value. So that means how many models will be trained? 2 into 3 into 2. So 4, 3, 12. So 12 models will be trained totally with all the 12 different combination, like L1 1e5 like 1e4, L1 1e5 1e3, L1 1e4 1e4, okay, and so on and so forth. Okay, grid search CV means like it will take all the combinations. There are two mainly search CV methods: randomized search CV and grid search CV. Anyone knows like what is the difference? Okay, so much to learn, right? So penalty, we just like copy paste it here. Okay, these are the penalty values we have to try. These are the alpha values we have to try, and then the tolerance values: 1e minus 4, 1e minus 3. Okay, the parameters. Now how to use grid search CV? Grid search CV, and there we'll pass in the SGD regressor, the actual model. Now in this, can we pass in the parameters directly here? Can we do this? Okay, no. See, I just need to like pass in some random state to maintain the uniformity. I'll just keep it 42. Okay, and we'll pass in the parameters. Okay, this is what is the data type of this parameters? uh, Dictionary.
Dictionary.
Dictionary, yeah.
Okay, it's a dictionary. For each, basically for each parameter we will try these list of values, and wherever we will get the best score, like the lowest loss, or the highest score, we can say, we will like simply consider that model. Okay, so now grid search CV, we have to pass in some CV value. What does CV means? This is in your uh, syllabus, right?
Yeah, it is.
It is.
Constant value.
No, no,
No,
no,
it's
not
cross
constant value.
validation.
Yeah, cross validation. I was not.
Okay, it will simply all of you know na what does cross validation means? Okay, like it will split the data set into 5 different portions, and for each it will train. So like how many combinations were there? 12. Okay,
12,
2
yeah.
into 3 into 2 into 3 6, 6 into 2 12. Now with this CV, that means 5 different uh like data sets, 5 different
Sample of data.
combinations. So 12 into 5, 60 different models will be trained. Okay, so you will be like from first model, from single model to 60 models. Yes, that is what we do in machine learning. Okay, now let's train it. GSCV, grid search CV, GSCV dot fit extrain TF by train. Okay, so now it is being trained. Okay, it's very fast. Why it is fast? Because SGD regressor gradient descent think it works like very fast. Now grid search CV, let me just go through this. Grid,
Why we are not transforming this
uh, transforming for what?
like this fit transform? Why
No,
we are,
fit means just to learn the model. Okay,
okay, so
there is
right
no
now we are,
transformation. What type of transformation would you do like while learning, like for building the model just have to learn the parameters, right?
yeah.
So this is what it is doing here. We just fit and predict. Okay, in model we just do these two things, fit or predict. Predict is to predict on test data set and fit is to train.
Yeah.
Okay, now classes CV fit estimator get params, there are many. I just want to, okay, I think okay, leave it. So we have to tell what is the best penalty. How can we tell like which one of these two penalty, L1 and L2, which one performs better? How can we tell that? Basically we have to like extract. So there is a parameter called best underscore params in grid search CV. It tells for each parameter what is the best parameter value this grid search CV has found. Okay, it automatically do all the run all the combination, train model on all the 60 combinations, and like find which model is having the best penalty, best alpha and best tolerance value. So best alpha is 1e5, this one. Best penalty is L2. Okay, and this 1e 3, 1e minus 3. Okay, so basically this is the combination, is the best combination grid search CV has found. Okay, now this is again a dictionary, we can get it via like this penalty L2. Okay, is this clear to you all? Okay, what is like, there are two names, easier names for L1 and L2. Anyone knows? One we have just used,
Ridge and lasso.
ridge and lasso. Okay, which one is which? L1
L2
is,
is ridge.
L2 is
L1 is
ridge
lasso.
L2
and L1
is
is
this,
lasso.
L1 is less. So
Okay, uh, now what is the mean absolute error on test data using the best SGD model? Okay, we have to tell the mean absolute error. So GSCV dot best estimator. So there is a parameter called best estimator which gives us the best model. Best model is simply like the model which is trained upon these parameters. Okay, now we have to tell the mean absolute error. How can we get the mean absolute error here? Simply dot predict x just tf. It will do the predictions. Okay, these are the predictions we got. Y pred, can we say this? Guys, is this clear to you all?
yeah.
Best estimator and predict, we are predicting with the best parameter with these values. Okay, now how to get the mean absolute error? Let me import it.
We have to import, yeah.
Matrix mean absolute error. So mean absolute error, first we have to pass in the actual values, y test, then prediction, and this is the mean absolute error. Is this low or is this good, this value? What do you think? No. Okay, it's very large. So we have to like still do a lot of hyperparameter tuning and a lot of things. Now okay, now this is a pipeline question with grid search CV. Now this is an interesting question. We are like integrating three different things: lasso with a pipeline of lasso plus PCA, and grid search CV on it. Okay, like hyperparameter tuning with these things. So first let's import the lasso and PCA. Okay, from sklearn.linear model import lasso from sklearn. How to import PCA?
From sklearn.decomposition.
Yeah,
Decompose.
decomposition.
What is PCA?
Principal
Principal
component
component analysis.
analysis.
Yes, principal component analysis. I hope what, like, not only the full form, you know what does it do. You must
I
have learned in MLT, ML a lot.
Reduces the dimensionality of the dataset.
Yes, dimensionality reduction, it is mainly for that. So we have to create a pipeline of what? First step is PCA. Okay, PCA, and second step is lasso. Okay, basically first we will do the like dimensionality reduction with whatever the data set we are getting in, and then we will create the model on it. So can I PCA lasso? Okay, I'll name it something like this, PCA lasso. This is the pipeline. Now we have to perform grid search CV. So let me create the parameters dictionary. Okay, let me do it fast. Parameters and components. Let me just copy paste it. That would be better. And components. Alpha. Okay. Now grid search CV lasso equals grid search. Now you tell me, how can I use this here? Earlier I used directly SGD regressor. Okay, how can I use this
You
here?
can use PCA lasso.
PCA lasso directly. Call
Yeah.
it here. Okay,
Yeah.
and params here, and CV equals to 5. Okay, there is one thing I can do: n jobs minus equals to -1. What does this mean? Anyone knows? So n jobs -1 means n jobs specifically, like it specifies how many cores do we have to use in our CPU. Okay, so -1 means to use all the cores at once, like to train our model as fast as possible. Okay, so lasso dot fit xtrain. Now there will be an error and you have to tell me how. Sorry, not xtrain, while train. Okay, we run, type error, pipeline object is not callable. Okay, okay, pipeline is not callable. Okay, so while running, this is a very big error we got. Invalid parameter alpha. Why invalid parameter alpha? Alpha is a valid parameter for lasso, right? And components is valid for PCA. Why it is saying invalid? See, we are not using the PCA directly or lasso directly. Okay, earlier we were using the SGD regressor directly, so we can directly pass the parameter names. But here we are using PCA under this name in the pipeline. So we have to remember this data set num underscore underscore from the column transformer. Okay, num underscore, and it has automatically created the prefix. So same prefix we have to provide in here. That is for the, like, we have to specify that n components is for PCA. How can we specify? We can specify like this: PCA underscore underscore n components. This means n components, this parameter is only for PCA, and alpha is for lasso. How can you specify? Lasso underscore underscore. Okay, is this clear to you all?
Yeah.
Now if let's say we have 10 different things in the pipeline, whatever the name we are using, we can specify the name here with the parameter values. If we run, it will run successfully, hopefully. Yes. So see, this is the grid search CV, estimator is the pipeline, PCA and lasso. Okay, what is the R2 score on best PCA plus lasso? Okay, how can we get the best estimator? You have to tell me. Well, I just like named the exact best
Best
estimator.
estimator.
Okay, this is the best estimator. And just to predict, um, okay, not predict. What do we have to do here? Score.
Yeah, score for R2 score.
Okay.
Yeah.
Before that, what is the best alpha value? This is what we have to figure out for the question 7. So best alpha value we want. Grid search C. Okay, let it dot best params. Now what is the best alpha value? 10. So see, in the similar manner we got lasso underscore underscore alpha. Okay, this is one underscore and then second. Okay, the best alpha value is 10 we got. Okay, is this clear to you all, the question?
Yes, yes.
I hope it is clear to everyone. And best estimator, now R2 score, just to score and X test TF Y test run. This is the R2 score. Is this good or bad?
Bad.
Bad or good? Really? Okay, what is the range of R2 score? 0 to 1.
Yeah, 0 to 1. 1 is, I think, best.
1 is best or 0 is best?
0 is best. 1 is, I think,
0
bad.
is best.
Yeah.
Okay, so is this good or bad?
It's good maybe because it's
It
near
is good.
to 0.
Like
Yeah.
compared to like earlier which we did, mean absolute error, this is way good, right?
Yeah.
So that means with on this data set, the this combination works very well, right? Specifically with these parameters, है ना?
Yeah, yeah.
So this is what actually machine learning is. Okay,
Yeah.
the same thing we have to do with various models we have to try. Now these are some extra questions. How much variance is explained by first principal component? You know, like the first principal component, how many like components? Okay, first principal component, how many principal components do we have here? How can we get that? Okay, GSCV lasso. Well, there is something best estimator we get. This is the PCA. Okay, now uh there is a thing called named steps. Okay, a parameter called named steps. uh this is for the pipeline. So in pipeline we have two steps, right? PC and lasso. We need to get the variance from the principal component, that is we have to get something from PCA. So how can we get something from PCA? We have to use the PCA specifically. We have to extract the PCA. To extract it, we need to use the named steps dictionary. Okay, if we do this, we'll get the PCA. Okay, see, earlier we got this estimator, now we got the PCA specifically. Now from PCA, we need to tell how much variance is explained. So explained variance. I think it might be, no, I think variance. I'm wrong. Maybe, I don't remember. But the exact, like the parameter is explained variance ratio. Uh, okay. Explained variance ratio, no attribute. Let's check. dir. Okay, this is right. Here we have explained variance. So like this is what the variance we got, okay, from the first principal component 0.9. okay, now how much like how much variance is explained, how much when it asks like the quantity, like how much, how much more, less and all. So you do not have to like you cannot provide this as the answer, you have to provide in like what is the ratio exactly. So this is the ratio 0.942, this is the exact answer, okay, when they ask like how much variance is explained from the first principal component, from the second principal component, and so on and so forth, okay. Well, these things you get by practicing only, okay. This is not something ki khud se aa jayega. I also like did practice and all. Now create a polynomial feature plus rigged pipeline. Can you guys do it on your own? It is similar to the above one, PC and lasso. Instead of PC we have to use polynomial features, instead of lasso we have to use ridge. Degree is 2 for polynomial features and alpha is 1 for ridge. Can you guys do
We
this?
can use pipeline here, right?
Yes,
And
similar
then it's
pipeline, okay. Instead of PCA just polynomial features and ridge instead of lasso, okay.
yes.
Now recursive feature elimination, it's very basic thing. Just use linear regression as the estimator, like the basically like evaluator, which will do the like which feature is best or which feature is least best and all, okay. Recursive feature elimination, I think you must have learned it in week 3 maybe or week 4. Week 3 I think, recursive feature elimination. So can you guys do this on your own? Question number 10. Like I do not want
Yeah,
to repeat the
10
same
is
thing,
easy. 10 is easy.
okay, because time is also like almost 10:30. And this is also easy, just like use RFE, and in RFE the estimator will be linear regression, okay. Which feature is eliminated first? You can see by the support parameter, okay. And train lasso, compute mean squared error. Is this easy? Train lasso with alpha as 0.1 and compute mean squared error on test data. Can you guys do it?
Yeah, it's easy. Yeah,
Yes, okay.
it's very easy. Yeah.
Train, ridge and lasso compares R2 score, which performs better. Is this easy?
We can also use pipe here, right?
Pipeline is not, like you cannot use pipeline here. Pipeline is to perform sequentially. These are two different things
Yeah,
that
yeah,
you
it's
have to
two
do.
different. So we can use, I think,
Hmm.
build it separately.
Now build a pipeline combining standard scalar plus ridge with alpha as 5 and compute MSC. Okay, this is a weird question, but I think you guys can do it, right? Is this possible? Basically what we are doing here is we are scaling down all the features with the standard scalar, okay, and then we are applying the ridge, okay. Just one more pre-processing step we are doing. Can you guys do all these questions, like just 5 questions, 10, 11, 12, 13, 14? I want you all to try
Can
because
you, can you do 11th one?
11,
RF. Yeah.
okay. I'll share the recording. Yes, it will be in my uploaded to my YouTube channel, okay, within just an hour after the session, okay. I'll do the 11 one. So let's me first import linear regression and RFE. So how can we import linear regression? Linear model, okay. Linear regression. How can we import RFE? Fast, anyone? It's a feature selection way method. Okay, so it comes under feature selection, RFE. Now RFE, and in that we have to pass in linear regression. That's it. RFE dot fit xtrain tf white train. Now basically in RFE we have to specify how many exactly features we would like to select. Most of the times they will provide like how many features do you have to select, okay, using RFE. If they do not provide, what you can do is you can take all the features or like less than one at least, so that it should eliminate at least one feature, है ना? RFE का like what is the usage of RFE? To eliminate all the unnecessary features which are not important. So what we can do is in features to select as xtrain df dot columns -1, or simply can I put in 6 here? There are 7 columns, so I need to select 6 columns. That means I need to eliminate one single feature, and that single feature we will see like what it will eliminate using the linear regression as the base estimator. Now how can we know like which is the exact eliminated feature? RFE dot support. Okay, yes. So RFE dot support true, 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 false, true. What does this mean? This means wherever we are getting like the false, that feature is excluded. Okay, so we can just get the index here. How to get the index specifically? Or okay, like if we do this x dot columns and RFE support, we'll get all the columns except that column which had the false. Okay, so how can we get that only false column? Like we want to know which feature was eliminated. This feature was eliminated, feature at this index value. How can we get that? Can we do argmin? Yes, we can. Okay, with the argmin we got the index, and with this index we can simply, okay, it should get load x dot columns and 5. So this is the feature which got eliminated. Okay, this is how we have to perform RFE. They will provide most of the, like mostly they will say like how many features we need to keep or eliminate. Then that like number we have to pass in here. Okay, is this clear to you all? RFE, if you have done like the practice assignment and GA, you know. If you have not copied answer. Okay, so yes, rest questions, can you guys do it on your own? The 4 questions, question 10,
Yeah.
12, 13, 14. Okay, so like is your preparation done at least somewhat, or like more than 50%, can we say, after this session?
Yeah, I think so.
Okay, now what to do next after this? Okay, what you can do is um, like I'll share a feedback form. I'll share all these links as well. So these are like all the links, like 1 2 3 4 5 6. So 6 links are there, 6 notebooks are there, plus this one. Okay, open these notebooks, practice yourself. Okay, so there are more than 100 questions in total, like 14 plus 13 questions here, rest like 20 questions here, 30 questions here, 20 questions will be here, and 20 questions will be like 15, 15, 30, and so on, like 30, 60, and 90, 110 plus these 30 questions. So you have almost 150, 130 questions, okay, to practice. So that will be enough for you to score more than 80 marks. If you like practice all these questions, even like most of them, easily you will be passed and easily you can score very well. MLP OPP is very, very, very easy compared to all other OPPs. Okay. Just make sure spend as much as less time in data pre-processing part. Okay. जितना जल्दी हो पाए, do it. Try to do it in 45 minutes. That is what I am saying, like practice as much as possible. And when you are practicing now, keep a timer in front of your, set a alarm clock of 45 minutes. Like you have to complete data pre-processing part in 45 minutes. Even if you are doing in 1 hour, that is also fine, but try to reduce the time. Okay, increase your speed, and that you can just do by practice, practice, and practice. And if you ever get stuck in any question, just paste the question in the comment of this video or any of the video, and you will, like, I'll share you the answer. And just one thing, if you okay, it is, yeah, MLP OPP sessions. So this is the playlist. It is having 1, 2, 3. Okay, these three sessions, session number 12, 13, and 22 for OPP1 revision. You can check out these 3 sessions as well. In all these 3 sessions, I have like done 3 different uh, sets of questions. Okay, so you have many more questions as well, and this is the link. Let me paste it. Okay, and I hope you all liked this session. Must have learned something new. आपकी थोड़ी practice हुई होगी, and all the best for your OPP, and hopefully okay, is there any quiz too?
No, there is no quiz to for ML.
Okay, so let's meet before OPP2. Yes, for G-form link. Please do fill this feedback form. It would be helpful for me. Okay. Very short form. Do fill it. And yes, I'll share all the links, the link of this as well, everything in the video description. Okay. Not for PDSA, but for MLP and Python, of course, I will. Okay, all the best, guys, and let's meet before OPP2. And all the best. Do your OPP well. If you get any sort of doubt, anything, you can ask in the comment section. You have like 3 more videos from which you can practice, and 1 to 6 different sets to practice. Okay, so you have many questions to practice. All the best and good night.